In the name of the Father. Little Buddha. Heart of Darkness. De Piano. Pak het drama in november op Filmnet.
April 13th, 1970. The crew of the Apollo 13 flight to the moon radios mission control with 5 haunting words.
Houston, we've had a problem.
Houston, we've had a problem. For 4 days, the world holds its breath as Jim Lovell, Fred Hayes, and John Swigert struggle to stay alive in their tiny lifeboat in space. Now, more than a quarter century later, a team of Hollywood special effects artists attempts to bring this real-life adventure to the big screen in the Ron Howard film Apollo 13. Coming up, we'll visit Digital Domain, where nearly 50 model makers, pyrotechnicians, and digital artists take the awesome images of space travel to new heights, from countdown to splashdown.
Fuel is go. All systems are go.
Next on Movie Magic. Today, a generation after these images of Apollo 13 first appeared on TV, actor Tom Hanks and director Ron Howard have teamed up to tell the true story of 3 astronauts nearly lost in space and the NASA engineers who rallied to bring them home alive. These filmmakers hope to recreate this compelling drama on film with unimpeachable authenticity and unparalleled impact.
When you hear one of the astronauts talking about one of these critical procedures, you realize it's life and death. But if you just showed it, it might not look like much. But if we could just tweak it here and tweak it there, then the audience would begin to understand what was at stake. So my job became one of interpreting that.
I think there's 2 kinds of special effects shot. There's the type that creates the fantastic and makes it look really cool. And there's the type that creates the fantastic and makes it look really real. And that's what all of the special effects were doing.
The man who leads the effects team is Rob Legato, who previously supervised visual effects on Interview with a Vampire and Star Trek Deep Space Nine. His crew members? The wizards at the Venice, California effects company Digital Domain. The first job is to get the Saturn V rocket off the launch pad.
Loop this thing back through here.
For all the rocket scenes, Legato uses miniatures. These precision models allow him to shoot scenes which are too dangerous or expensive to shoot full scale. Certain shots can be filmed using only a section of a rocket. Legato uses an 8th scale replica of the rocket's first stage for a low-angle view of the rocket engines cooling prior to ignition. For many scenes in the launch sequence, Legato will use composites, combining shots of the Saturn V rocket miniature, background footage of Cape Canaveral, and smoke and flame elements shot on stage.
You have to take a model, put it against a Cape Canaveral background in broad daylight with nothing to hide behind. And then on top of that, you have to create elements that absolutely replicate this real event, which is so well documented and is so ingrained in people's minds that any falsehood would ring out.
Looks good here, flight. Good agreement. Okay, boost that, Ela. That's what they look good.
Pyrotechnics expert Joe Viscosal is called in to create the ignition explosion so crucial to the film's dramatic launch here in the Digital Domain parking lot.
The biggest challenge for me today is to make the miniature look as good as all of the shots that NASA has provided in the past with their cameras. And the big trick is to try to make this explosion look like theirs. The challenge is really to make the small look big. There's a lot of variables involved in that. The size of the model, the type of chemical materials that I use, the speed of the camera, and so forth.
So we're going for something that has a little more visceral quality than anything you've seen before. So the cameras are wide and up very close, and we asked Joe to make the flames go almost straight into the camera lens, which, if you shot it for real, it'd just blow out the camera.
In anticipation of Joe's excellent aim, each camera is protected with a blanket of fireproofing material and a polycarbonate shield over the lens. Viscosal's incendiary brew will replicate the look of the kerosene and liquid oxygen burn produced by the actual Saturn V. Legato is shooting this scene at 240 frames per second, 10 times faster than normal, to get the slow motion shots director Ron Howard wants for the launch sequence. Two Photosonics cameras, renowned for their ability to film with exceptional precision at very high speeds, are trained on the model. The Photosonics were in fact originally developed by NASA to document their own launches. Appropriately, they are now being used to capture this cinematic launch.
It's kind of amazing as we're using the same camera, not to shoot the real item, but to make the miniature look like the real item.
Hey, Rob, real close, 2 minutes.
In the final moments before the explosion, the crew wets down the deck and places fire extinguishers to prevent the spread of some very real flames.
Okay, roll camera.
Then hours of preparation meet with success or failure in the blink of an eye. For Apollo 13, shots filmed on set called practical elements only begin the filmmaking process. When a piece of film enters the digital world, it begins an extraordinary evolution. The processed film goes first to editorial, where key shots are selected. The negative of these shots goes to digital input scanning. Here it is digitized, 1 frame at a time, at a rate of 40 seconds per frame. The scanner transforms the photographic images into the bits and bytes readable by Digital Domain's powerful silicon graphics computers. Once the images are on disk, digital artists apply their own creative magic to achieve and enhance the filmmaker's vision. Adam Stark is working on another shot in the launch sequence, integrating flames shot in California with a background of the Florida launch pad.
Basically, you have to have an overall view of the scene that you're working on and take whatever it is, whether it's a practically shot element or computer-generated piece of fire, and blend it in so that you're creating an original piece of artwork after that. And whether it serves its purpose in the movie is the final judgment of the work that you do.
Digital compositor Mark Forker has been assigned another of the dramatic shots in the sequence, a view of the launch from beneath the rocket. The composite begins with a background plate that was filmed on location at Cape Canaveral, complete with the tilt-up you would see as the rocket lifts off. To this background, Mark adds the Saturn V rocket and the gantry, both shot in miniature on the Digital Domain stage. Then come computer-animated plumes of fire. Next, Mark adds reflective lighting on the gantry and the underside of the rocket. After 8 weeks of work in computer graphics, all of these elements are composited together. When the shot is finally completed on the computer, it is output via another scanner back to film. Add sound effects, and the result is a persuasive interpretation of an awesome moment in history. Every bit as believable as the original coverage, but with all the movie magic of a Hollywood adventure.
Houston, we have cleared the tower in 1313.
When the Apollo 13 crew faced its darkest hours in space, it took a monumental effort to bring the 3 astronauts back to Earth. One key member of the team in Houston is now a technical consultant to director Ron Howard.
Few people realize that during the peak of Apollo, there were 400,000 people working directly on the program. And when Apollo 13 had its problem, all those people had to pull together to get the crew back safely.
Many of those thousands worked in the 500-foot-tall Vehicle Assembly Building, or VAB, where the Saturn V rockets were stacked and tested. Filming on location there would have required lighting comparable to that of a small city. So Ron Howard asked visual effects supervisor Rob Legato to create the VAB scenes, combining miniatures and live-action photography with the actors. In one of these scenes, astronaut Jim Lovell, played by Tom Hanks, escorts a senator and his entourage on a tour of the vehicle assembly building. First, Hanks and other actors are photographed against a green screen, a temporary background which will later be replaced with a shot of the VAB. The Digital Domain model maker's assignment is to recreate a portion of the VAB in miniature. Their model is to have the feel of a space-age cathedral. The VAB model is designed at 1/24th scale, 13 feet tall, 15 feet wide, and 20 feet deep. It is assembled of vacuum-formed styrene walls and a grid of injection-molded plastic onto a structure of thin-wall steel tubing. 8 model makers spend more than 1,500 man-hours constructing and dressing this miniature. Model shop crew chief Leslie Ecker believes that giving individual model makers the freedom to innovate helps produce better models.
Each model maker was given 1 or 2 rooms to do, and I was very vague about the instructions purposely because I just wanted each room to be very different.
Detail is a big part of what makes models believable, and the VAB has plenty of it. More than 500 lights in this miniature are powered by variable transformers. The lights are soldered onto 1/8-inch copper welding rod, which carries the power to them.
And just from experience, we know just about how much detail you need to have. And we'll usually also make a cache of detail to put in to dress to camera, because we often have to shift pieces around and dress out areas that are seen better in some angles than in others.
Throughout the model, miniature stairwells, hallways, trash cans, and gas tanks add to the on-screen realism. The result is a highly detailed, realistic rendering of one of the world's largest buildings, complete with a Saturn V rocket. A big part of creating special effects is trial and error, getting down and dirty to discover what works and what doesn't.
Oh, looks good. Looks like it's not twisted.
While model shop team leader Gene Rizzardi and his crew perfect the navigational system on this tiny forklift, Ecker has another problem to solve. Though computers have greatly improved the compositing capabilities on film, combining miniatures and live action is still a tricky business. In this case, the team is working on another angle of the VAB interior. They must line up their background shot of the models with live action footage of the actors shot weeks ago. The miniatures are filmed using motion control, a computerized camera technique that allows visual effects director of photography Eric Nash to program and repeat each move precisely. The movement of the motion control camera on any given frame must exactly match the movement of the live action camera. This time they fail to align because of minor unsteadiness in the live action footage.
Unless they're in alignment, when you get the 2 elements rolling with each other, their axes won't match. So you'll get some sliding of one element to the other. But if their axes match, their rotational axes match, they're locked together during the move, and it looks like it was really there.
The effects team shoots as close a match as possible. Then Rob Legato takes the shot to the digital artists. In the computer, the elements are finessed frame by frame, resulting in a scene so believable that audiences will be convinced Tom Hanks and company toured the halls of the real VAB.
Imagine if Christopher Columbus had come back from the New World and no one returned in his footsteps.
Attention all personnel. Clear level 3.
Are there any other questions?
The most memorable moment in the real Apollo 13 story was the safe return of the astronauts to Earth.
Splice down at this time.
For the Apollo 13 film, the effects team has been challenged to recreate this historical event using miniatures. The question is, with the laws of physics remaining full scale, will the miniatures look real? At Digital Domain, model makers build 3/4 scale miniature capsules out of epoxy glass and mylar. At a nearby sail shop, craftsmen produce 3/4 scale nylon parachutes, 21 feet in diameter. Each has 64 alternating orange and white panels and 64 lines of nylon ribbon to attach the chutes to the capsule. Weeks before the actual shoot, the crew travels to Taft, California for a test drop. Not until they deploy the capsules will they see if they have accurately anticipated the laws of physics. First, a helicopter is carefully positioned on a platform of plywood boxes to give the effects crew room to work. Once the chopper is secure, they assemble and clamp a 3-arm drop rig to the bottom of the Bell Jet Ranger. This frame of telescoping steel square tubing positions the 3 chutes precisely.
Ready? Okay, ready? Up and in. That's it. Now, are we sure we're hooked here?
A 1,500-pound capacity hook attaches the capsule to the chopper and will allow for precise deployment. Parachute coordinator Mo Valletto ensures the parachutes are properly rigged. The test will provide visual effects supervisor Rob Legato with valuable information before they film the real thing.
It's essential just to make sure everything we have covered. It may need that the capsule needs more weight to make it look more realistic. All the technical things with the drop line to make sure they deploy at the right time, and all those particular items that you have no idea. In theory, it all sounds good, but until you actually do it, you don't know if it's going to work or not. Now you should get this. We're going to see if the guys are alive inside.
From the test, the effects crew discovers that they need to add 100 pounds of weight to the capsule. They hope the added weight will increase vertical airflow to make these chutes perform the way the real chutes did on the Apollo 13 splashdown. When the day arrives to film the scene, so does the entire effects team at Little Harbor on Catalina Island off the coast of Southern California. Legato hopes to film 3 drops today with the 1/4 scale models.
Is there one ready to go?
I believe that first.
That one? Okay, I'm going to get it on the forks then.
The model shop crew adds 25-pound bags of lead shot to bring each capsule up to 300 pounds. Then, to keep them afloat, the capsules are filled with 2-part urethane foam and styrofoam and sealed with a neoprene gasket. Legato plans to cover the drop with 5 cameras, 3 on the bluff and 2 in the air. 2 Jet Rangers fly in tandem for each drop. The camera ship is equipped with a gyroscopically stabilized camera. This will allow for dramatic, almost vertical aerial shots of the drops, minimizing helicopter jitter. Eric Nash will also be shooting from the air, but with an added thrill. He'll be standing on the skid of the drop helicopter. Nash wears an empty base jumping rig, normally used for parachuting from stationary objects like bridges.
All we're really using it for is to have a couple of points to tie me to the helicopter, so while I'm standing on the skid, I can lean out and look straight down without seeing the skids or my feet.
About 100 yards from the helicopter drop point, ground cameras are fitted with telephoto lenses and lens extenders to provide focal lengths up to 2,000 millimeters. With lenses this long, just keeping the capsule in frame can be the toughest challenge. To make it easier for the cameras to get their shots, the pilot attempts to hover while he deploys the capsule. When he's completely ready and the ground cameras have locked in on the capsule, all 5 cameras roll.
5, 4, 3, 2, 1.
With a single purpose, the entire Digital Domain crew focuses on this final, heroic moment in the Apollo 13 story, to get the shots they've come for.
And 5 seconds splashdown.
For one of the astronauts who actually lived this adventure, the Apollo 13 movie provides an important new perspective.
After the initial euphoria of getting the crew home back in 1970,
NASA and in general the public wanted to forget about this flight. But then after a long period of time, people suddenly realized that it was really a triumph in the technology and the teamwork and the motivation of the people on the ground working with the flight crew to get this crew home safely. So now I think it's really worth telling. It's a true American adventure story.
A story the telling of which was also a tremendous challenge, requiring the same kind of ingenuity and teamwork that NASA engineers demonstrated in 1970.
When I first started working with special effects people, I thought that, well, this is going to be dry and they're technically adept and I'm not. And I instead found it to be, wildly creative. With Apollo 13, it had to be realistic and even a kind of hyper reality. And that's always hard to come by in the special effects world. It's the greatest challenge.
From the dramatic, even impossible shots of the launch, to the interior workings of NASA's rocket cathedral, to the majestic climax of the astronauts' return to Earth, Rob Legato and the effects crew at Digital Domain prove again that they have the right stuff to bring all the reality and adventure of movie magic to the big screen.
The ultimate compliment for any type of work this way where you're trying to replicate real life is no one knows who did it. If no one knew, it just was this exciting launch space film exactly the way they remembered it. That would be the highest compliment.
Houston, that ship is secure. It's Apollo 13 signing off.